Hello there, ladies and gentlemen. So today we're going to be talking about the ellipse. So the ellipse is just like a stretchy circle. It's been stretched out to the side. Okay. And so same thing, the center is going to be all X, Y, and all that good stuff. But the main focus of an ellipse are these things called the foci. Okay. The individual ones are called focus, but the plural form, in other words, the multiple version is foci. Okay. And so what's special here is that the distance, and I'll do this in red, the distance d1 and d2 from any point in the circle are always going to be constant if you add them up together. So let's say I picked this spot. From here to here will equal the exact same amount as if it was from here to here, like no matter how you add them up. Okay? And so that's what's special about the foci. All right. Now, here are the rules for an ellipse that has a center at 0, 0. Okay. So sometimes you're going to have a horizontal ellipse. Those are the ones that stretch left and right. Okay? And then you have a vertical ellipse, the ones that go up and down. So here's how you know. You can tell because of the bottom right here. I'll do it in green. You have a squared is underneath the x squared. And notice how on the vertical ellipse you have b squared underneath the x squared. A is always going to be bigger than b, no matter what. A will always be bigger. So in this case, if a is underneath the x squared, then it stretches along the x-axis. It goes this way and this way, okay? And then if b is underneath the x squared, then it goes vertically. It stretches up and down. So it goes here and here, okay? And so another way to say this is a is going to be underneath, a is going to be underneath the y squared. And so a always goes underneath where the stretch is going to go. So the stretch goes up and down, as I said a couple seconds ago. Okay. Now let's label some of these things. This is right here, what I highlighted in green is the minor axis. The small one is the minor axis, the one that's denoted by the letter B. And then the long one is called the major axis. That's the one that we denote with the letter A. Okay. So now let's label some other things here. So in this case, what I just said, the major axis is on the x-axis, and the vertices are a comma 0 and negative a comma 0. In other words, right here and right here. Okay. Now the length of the major axis is 2a because here's one distance, positive a, so a comma 0, and then here's another distance of a. When you add them together, you get 2a. So that's just a plus a. The minor axis, which I'll do in blue, goes here to here. So that's the distance b and negative b, but all I care about distance, so no negatives. So this is b plus b, which is 2b. Okay, now let me erase that so you can see better what I'm about to do. And then the foci are always going to be on the major axis, and they're going to be directly in between. Now, the reason why I have the midpoint formula right here is because the foci are always right in the middle of the center and one of its what's it called? One of the axes. Okay, in other words, the major axis. You could also find the center. Sometimes they're going to give you both vertices, so they're going to give you this and this, two vertices, and then you got to find the center. In this case, it's at 0, 0, but you could calculate that using the midpoint formula. Okay, and then you would do the same for if they gave you both minor vertices, you could find the middle right then and there. Okay, or maybe they gave you both foci and you got to find the center. Well, you could do that. Okay, and that's how you do the horizontal. For vertical, it's pretty much the same idea. Okay, it's actually exactly the same idea, except everything goes backwards. So the vertices, the major vertices, would be one right here and one right here. It goes up a, down to negative a. If you combine them, in other words, just the distances, you get a plus a. Same thing for the minor axes, which I'll do in red. You have this distance b and this distance negative b, but because distance cannot be negative, so essentially I'm taking the absolute value, it's just b plus b. So b plus b, and that's how I get 2b. The foci in this case, so I'm going to delete this, the foci are right here, in between the center and the major vertices. So don't forget, that's where they're at. Okay. Now here's a little diagram right there. There's two thumbtacks, and you can pretend that these are strings. Oops, sorry. You can pretend that these are strings. And so the thing about this is that this pencil can make it all the way around because essentially they're like stretchy strings. So as one shrinks, the other one grows. And so you would be able to make it all the way around, no matter where you were, perfectly around the ellipse. Okay. All right, so let's actually do an example. So we're going to find the following for the ellipse with all the questions that they're asking for. So let's actually give it a shot. All right, here we go. So this is at the center. So the center is 0, 0. Notice we have no h and k right here. Okay, so no h, no k. Now, a is always the bigger number, okay? So the bigger number would be 36, but that's a squared is 36. If we square root both sides, a equals 6. So now we know that a is 6. B, same idea. I'll do that one in blue. So b squared is 16. And so regular b, if we square root both sides, is just going to be the square root of 16, which is 4. In this one, you don't need plus minus because the numbers are just positive. Those are the distances. All right, so major vertices. Now remember, this lies on the x-axis. So because A is underneath the x, it is a horizontal, which is great. That means I'm going to go, and I'm going to use red, 6. So 1, 2, 3, 4, 5, 6. I'm going to go 6 this way and 6 backwards. So 1, 2, 3, 4, 5, 6. All right, those will be the major. And so the major vertices are going to be 6, 0 and negative 6, 0. Okay, because this is 6, 0. It's moving on the x, not the y, and negative 6, 0. So hip hip hooray, we have those. Now the minor axes, which I'll do in blue, those go up and down in this case. And they go up 4 and down 4. So up 4, down 4. So 1, 2, 3, 4. 1, 2, 3, 4. And there we go. So I can label that as 0, 4 and 0, negative 4. And so we could do that right here. Okay, good. We have that. And so now we can actually draw our ellipse. Draw this as best as you can. Again, not looking for perfection. You don't have to be a great artiste. Okay, there you go. There is my very badly drawn ellipse, but an ellipse it is. All right, now to find foci, that is the letter C. Okay, so foci is usually denoted by the letter C. And so we can actually calculate this. So to figure out letter C, I have a little formula right there that you should memorize. You don't have to if you don't want to, but I highly recommend you do because it'll make your lives a lot easier. Now we know the foci are going to be on the x-axis. And so here's what we're going to do. We use the little formula, c squared equals a squared minus b squared. We already know a. We already know a squared, which is 36. And then b squared is 16. Subtract, we get 20. So c squared equals 20. And so now that we have this, we can calculate. We can square root both sides. So c equals the square root of 20, which really this is just the square root of 4 times the square root of 5, which once we calculate, that's just 2 square root of 5. Okay, and so since the foci goes here and here, okay, it's not exact. So now we can calculate. So this will be -2 square root of 5, because it's 1 from the negative side, and then 2 square root of 5, 1 from the positive side. So those are the two. Now, eccentricity is just how round so this word right here, eccentricity is how round the ellipse is. Maybe it looks kind of like this, or maybe it looks like this. The eccentricity is a number. And so the number up here, I'll highlight that in green. The eccentricity is C divided by A. And so C was 2 square root of 5. So E equals, and then A was 6. And so we can simplify that a little bit. That'd be the square root of 5 over 3. And so the bigger or smaller this number is, the closer, so if it's closer to 1, it's flatter. Okay, so right here, closer to 1, then it's flatter. So it'd be more like this. And then the closer it is to 0, the rounder it's going to be. Okay, so that's how you calculate those things. And something I actually forgot to mention is we actually have to draw the foci. So to draw the foci, I just look at the original C value that I got, square root of 20. And then I think of a number that's close to that I know how to get the square root of. So like think of the square root of 25. The square root of 25 is 5. So that means the square root of 20 has to be a little less than 5. So I'm going to count to 5. So 1, 2, 3, 4, 5. Whoops. So 1, 2, 3, 4, 5, and then a little bit less than that. So probably between 4 and 5. So right there. By the way, I also know the square root of 4. Sorry, the square root of 16, which is 4. So I'm somewhere in between 5 and 4. So again, 1, 2, 3, 4, 5, and then a little bit less than that. And there we go. There are my foci. Okay, so that's how we're going to do that part. Alrighty, so now what happens when we have actually H and K to worry about? So just like before, A is going to go underneath whoever the biggest axis is going to be. So like before, if it's underneath the Y, like as we see right here, then this is going to be vertical. Okay. And if it's underneath the X, then it's going to go horizontal. Okay, it's very similar. Actually, almost the entire process is similar. How to find the major and minor axes is the foci, but we just have to take into consideration that the center is not 0, 0 anymore. So let's take it a shot. So right here, my center, so remember H's go with X's, K's go with Y's. So my center is going to be at 2, comma, -4. Okay, remember you think opposite of what's going on. And then now this is going to be A squared because that's the bigger one. And this is going to be B squared. And so since the A squared is underneath the Y, I know that this is a vertical. Okay, so now I need to figure out the square root of 49. So A squared equals 49. So A equals 7. Okay, so A equals 7. And then we have B squared equals 16. So then we have here B equals 4. Okay, awesome there. So we already have a whole bunch of information that's going to help us out. First things first, let's go plot our center. 2, comma, -4. Remember, this is X and Y. So we go 1, 2. So 1, 2. Whoops. And then 1, 2, 3, 4. Okay, awesome. So our center is right here. Now I'm going to delete these, that way they're not in the way. So there's the center. Okay, now a major vertice, since we already know that A is dealing with the y-axis, okay? So this is all about the y-axis, and this is all about the x-axis, because A was underneath the y. So that means I have to go 7 up and 7 down. So let's go ahead and count it out. 1, 2, 3, 4, 5, 6, 7. Okay, great. So here's one vertice. Now let's go down. So 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to draw little tally marks right here. Actually, let me draw that a little bit better. So let's see, 1, 2, 3, 4, 5, 6, 7. So let's just put it right here. Put my tally marks right there. I don't know why the computer is wigging out on me. So 1, 2, 3, 4, 5, 6, 7. All right, there we go. I just want to keep the tally marks there so we can still see what's going on. Alrighty, good. So there are our two major vertices. This one is at, let's see, so this one's at 1, 2. So 1, 2, 2, comma, 1, 2, 3. So that one's at 2, comma, 3. And then the other one is at 1, 2. So let's see, 1, 2, and then it goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it went down to 11. So this one is 2, comma, 11. Now let's see what happened. So we just counted them out. And notice the major vertice in this case, the 2's are exactly the same. The 2's never changed. The only difference was the y value. And so the y value, you just have to add 7. I'll say I shouldn't draw that in green. I should do that in red. So I only needed to add 7 to these two, to the -4 and subtract 7. And so that's what gave me the values. By the way, this is -11 because it went down. So notice the relationship when dealing with the major vertice and it's a y-axis ellipse. The y-axis is the part that changes. And so now let's see what happens when we try to figure out the minor vertices. Now remember, minor vertices are all about the letter B. So major A, minor B. So let's see, the B is a 4. So I go to my center and I go 4 to the front. So 1, 2, 3, 4. So there it is. And then 4 back. So 1, 2, 3, 4. Put it right there. Alrighty. So those are my minor. So to figure that out, well, let's just go ahead and figure it out manually. So I went back 1, 2, and then 1, 2, 3, 4. So I went back 2, down 4. And the other one was 1, 2, 3, 4, 5, 6, and again down 4. So 6, comma, -4. And now let's check the relationship again. So this relationship, let's see. I started with -4 on the y, and look at that. The y values are also -4 on the minor axis. So the only one that had any change was the x values. How did those change? By adding and subtracting the b value, the 4. Okay, so now we can see how those are related. That's great. Okay, so let's go ahead and move on. Now, the foci are a little tricky. Okay, so the foci start at the center, and then they move by that letter C from before. Let me show you over here. This letter C that we figured out before, that's what we did. Okay, so I have the formula right here. I'll do that in red. The letter C is a squared minus b squared. So let's go ahead and do that really quick for the foci. So let's see. Letter C was, C squared is a squared minus b squared. And so I already know a squared, that's 49. And I already know b squared, that's 16. So that means that c squared is actually going to be 33. And therefore c is the square root of 33. That one doesn't really simplify anymore, so that's it. And so now to figure out the foci, I already know that the foci has to be on the major axis, which I will highlight or draw in red. So this is your major axis right here. Okay, minor axis will be in blue. So my foci have to be somewhere here, okay? Which means that the x value will never change. The x value will be the same. So my foci will be 2 comma, because it's always 2 to the right. And then now I'm going to add square root of 33 to the negative 4, to the y value. So it's going to be negative 4 plus the square root of 33, okay, because that's going to move it up. Okay, that means the foci is going to be somewhere over here. And then the other foci is the one that goes down. So 2 comma negative 4, because that's the center, and then minus the square root of 33. All right, now let's think about the square root of 33. That is very close to the square root of 36. And I know that is 6. So it's a little bit less than 6. So what I'm going to do is I'm going to go up 6 and count it out. So 1, 2, 3, 4, 5, 6, and then a little bit less. So let's say around right here. So there's 1 foci, and then same thing, 1, 2, 3, 4, 5, 6, and then a little bit less. And there's my other foci, or my focus, my other focus. And so there I have now labeled all my foci, everything's great. While we're here, why don't we just draw out the ellipse? So connect your dots as smooth as you can. So there we go, there's the ellipse. And now the eccentricity, that one is not too complicated. We already labeled that on the previous one. E is just C over A. So let's see, the letter C we just figured out is a square root of 33. And A was 7, so this should be the square root of 33 over 7. That is definitely less than 1, because square root of 33 is a little bit less than 6. And as you can see, that number is really close to 1, so it's a lot flatter than it is rounder. And now finally, the length of the major axis. The formula for that is 2a. And since we already know that a is 7, so this would be 2 times 7, which gives us 14. That's how long the major axis is, the red line. The length of the minor axis is 2 times b. So in this case, it would be 2 times 4, which gives us 8. And there is the length of the minor axis. And so there you go, ladies and gentlemen. That is an ellipse that isn't on the center. Okay? So we'll talk about this more during class. So thank you so much for watching the video. I will see you all next time.